Hi class. In this video we'll work with complex numbers. So let's get started. Complex numbers result from taking a square root of a negative number. Say we have a square root of a -4. Well, that's going to be equal to, well, you can't do that unless you have imaginary numbers. So the square root of a -1 we call I. So therefore I squared is equal to -1. So the square root of -4 would be equal to a square root of 4 times the square root of a -1, and that would be 2i. Now in general, a complex number is written in the form of a plus bi, where we have a real part and an imaginary part. And that's basically what a complex number is, just a plus bi. So with any numbers, we can add, subtract, multiply, and divide. So let's do a few examples. If we have two complex numbers, say 2 plus 3i, and we can add a 4 plus 5i, okay, say this complex number and this complex number, then we just add them and we add the corresponding parts. The real parts is 2 plus 4, we get 6. And then we have imaginary parts, we have 3i plus 5i, so that's 8i. Second example, say we have 4 minus 2i, and we add, say, 7 plus 5i. Now, 4 plus 7 is 11, and then we have a minus 2i and 5i, so that's 3i. Let's hear it add complex numbers. Let's subtract a few. Say we have 4 plus 6i, and we subtract off 2 plus 3i. Okay, well, 4 minus 2 is 2. 6i minus 3i is 3i. So there's our complex number. Say we had 4 plus 6i, and we subtracted off 3, say minus 4i. All right, well, 4 minus 3 is 1. That's the real parts. And the imaginary parts is 6i minus a negative 4i. Well, minus a negative is positive, so it would be plus 10i. So what about multiplying numbers? Well, we could have 2 plus 3i, and we could multiply that by 4 plus 2i. And how do we do that? Well, we just do the distribution. We distribute 2 across these, and then we distribute the 3i across those, just like we would any numbers like these. So 2 times 4 is 8, and 2 plus 2 times 2i is 4i, and then 3 times 3i times 4 is plus 12i, and the last one is 3i times 2i is 6, but that's I squared. Now remember, I squared is equal to minus 1. So when we combine these, that's going to be plus a negative 6 over here. All right, that turns into a minus 1. I squared is equal to minus 1. So that's minus 6. So we get 8 minus 6 is going to be 2. And then 4i plus 2i plus 12i is plus 16i. And there's our final result in the form of a plus bi, the real part and the imaginary part. Okay, let's do another example. Say we have 3 plus 4i times 2 minus 5i. All right, well, 3 times 2 is 6, and 3 times minus 5i is minus 15i. 4i times 2 is plus 8i. And then finally we had minus 20i squared. Okay, so that will be a plus 20 since I squared is just equal to minus 1. So 20 minus 20 times minus 1 is 20. So we can add 6 and 20, we get 26. And then minus 15 plus 8, that's a minus 7i. And there we go. Okay, we could also have something like 3i times 2 plus 4i. And then that would just be 6i plus 12i squared. I squared is minus 1, so we just have minus 12 plus 6i. And that's in the form of a plus bi. So there's negative 12 real parts and 6 imaginary parts. Okay. We could also have division. 2 plus 3i divided by 3 plus 4i. And how do we do that? Well, we multiply by what's called a complex conjugate. And that is just that if we have a plus b times a minus b, that's equal to a squared minus b squared. Okay, and that will get rid of the i's on the denominator. We're trying to get rid of the i's in the denominator, so it's kind of like rationalizing the denominator. But so we multiply by 3 minus 4i and top by 3 minus 4i. This number is just equal to 1, so we're not changing it. And what do we get? Okay, well, we'll get on the top, okay, we get 6 minus 8i and a plus 9i, and then finally a minus 12i squared. On the bottom, we get a 9, and then minus 12i, and then we get the plus 12i, multiplying this one times this one, and then we get a minus 16i squared. Okay, so that's equal to, well, I squared is minus 1, so that's 12. 12 plus 6 is 18. Combining the i's, we get just an i. In the denominator, we get 9. This one cancels with this one. Minus 16i squared. I squared is minus 1, so that's 16. So we get 25 in the denominator. And notice there's no i's in the denominator. So that can be written as 18 over 25 plus 1 over 25i, and that's in the form of a plus bi, an imaginary number. Let's do one more of those. Let's see, we have 5 minus 4i over 3 minus 2i. How do we do that? Well, we multiply by the conjugate, so 3 plus 2i. And that will get rid of the i's on the bottom. And we have to multiply by the same thing up top. So that we're just multiplying by 1, and we're not changing this number. So if we multiply that, let's do the denominator. We get 9 minus 2i, 9 plus 6i. Then we get a minus 6i. And then finally a minus 4i squared. On the top we have 5 times 3, which is 15, plus 10i, and then minus 12i, and then we have a minus 8i squared. I squared is a minus 1, so that becomes 15 plus 8 is 23, and the i's have minus 2i. In the denominator, the 6i and minus 6i cancel. I squared is minus 1, minus 4 times minus 1 is 4, 4 plus 9 is 13, and so that is equal to 23 over 13 minus 2 over 13i, and there we have it. Okay. Okay, the last idea with complex numbers, no pun intended, idea, is we can say, well, what's I to the 6th equal to? Well, I to the 0 is equal to 1. Anything to the 0 is 1. I to the 1 is equal to 1. I squared is equal to minus 1. I cubed is just equal to minus 1 times I, so it's a minus I. And I to the 4th is equal to minus I squared, which is a minus 1, which is 1. So I to the 5th is equal to I, right? And I to the 6th is equal to I squared, which is minus 1. And the whole pattern keeps going, right? We start getting 1i and the whole thing. So this one's equal to a minus 1. What about I to the 13th, say? Well, that's equal to I to the 12th times I. Every time I to the 4th is just equal to 1. So that's going to be 1 times 1 times 1. It's 1 times I. And I to the 13th is just reduces to I. Okay. What about I to the 22nd, say? Well, that's equal to I to the 20th times I squared. I to the 20th is just 5 times I to the 4th, right? That's equal to I to the 4th to the 5th times I squared. Every I to the 4th is 1, so that's just equal to I squared, and I squared is equal to minus 1. So I to the 22nd is equal to minus 1. Okay. I to the anything, we'll just say 31. Okay. Well, we basically take 31 and divide it by 4. 31 divided by 4 is equal to, well, 32, it's 28, and it's 3. So it basically reduces to I to the 3 times I to the 28. To the 28 is a multiple of 4, so that's just equal to I cubed, which is I squared times I, which is just equal to a minus I. So you can just get the remainder and then go back a slide. If you get what's remainder is a 3, then you get minus I. Get this one right there. And just reduce the remainders. So since you got 3 left, you get a minus I. If we did an I to the 42nd, that's equal to, divided by 4, the remainder is 2. That's just the same as I squared, which is minus 1. Okay, well, I hope this adds to your understanding and you enjoyed the video. Cheers.